Okay, let's solve quiz 9. So, basically this is the KPR calculation. It's the corrosion rate, and, sorry, CPR. CPR equals KW over rho AT, and that was from the back. And I gave you this little table, and the table tells you that if you want your CPR in units of MPY, that the K value is 534, your weight is in milligrams, your density is in grams per cubic centimeters, your area is in square inches, and your time is in hours. Whereas if you want your solution in millimeter per hour, you use a K value of 87.6, weight in milligrams, density in gram per cubic centimeter, area in square centimeters, and time in hours. So to solve this in MPY, we would do 534 times 485, that's grams, but we want milligrams, so that's going to be times 10 to the 3 milligrams. Divided by the density, and I gave you the density in class. Rho is equal to 7.9 gram per cubic centimeter, so that's in the right units. 7.9. In MPY, we want area in square inches, which is what the problem gave us. And then we want 1 year, which is 365 days times 24 hours a day. And all the units are right, therefore we get 37.4 MPY. 37.4 MPY. If, on the other hand, we wanted a corrosion rate in millimeter per year, then we have to change that. CPR K value now is 87.6. 87.6. The same weight, 485 times 10 to the third milligram, divided by density, which is correct. Now this area, that is in square inches, which means we need to convert that to centimeters, square centimeters. So that's going to be times 2.45 centimeters per inch. So inches, centimeters per inch, or sorry, inches squared, centimeters per inch times centimeters per inch. Get the units right, times 365 times 24, and that's equal to 0.952 millimeters per year. 0.952 year. That's the first problem. Next problem is about calculating the number of free electrons per cubic meter of silver, and that's just basically a unit problem, right? So we've got 1.3 free electrons per silver atom, and we have the density, which is giving us grams per cubic centimeter. So we've got to convert grams per cubic centimeter to atoms per cubic centimeter. So let's do that. 10.5 gram per centimeter cubed. And we've got the atomic weight, which is gram per mole. So that's going to be 1 over 107.87, and that is gram per mole inverse. So now we got mole, and we need to turn mole into atoms. So that is times 6.02 times 10 to the 23 atoms per mole. So that means that grams cancel, mole cancels, we get atoms per cubic centimeter. We got to get rid of the cubic centimeters by saying 100 centimeter cubed per 1 meter cubed. And that's going to give us atom per cubic meter. And then we're given 1.3 electrons per atom, so times 1.3 electron per atom. Atoms cancel, so that gives us free electrons per cubic meter, which is 7.6 times 10 to the 28 electron per cubic meter. Times 10 to the 28. You don't have to put electron in here if you want to. You just have it per cubic meter. The next question is about mobility, and we're given the conductivity, and we have the number of free electrons, we have the charge on the electron, therefore we have everything in the equation. Sigma equals n e mu, given, known, determine the mobility. So mobility is equal to sigma over n e, and that is 6.8 times 10 to the 7 I'll put the units in afterwards. N is 7.6 times 10 to the 28, and E is 1.602 times 10 to the minus 19. And the units on all of this is inverse ohm meter. This is per cubic meter, and this is coulomb. So ohm can also take units of volt per amp, which is volt per coulomb per second. Which means this could be meter cubed per volt second coulomb meter coulomb. Coulombs cancel, meters cancel, leaving us with units of meters squared per volt second. Admittedly, in terms of grading this, there's flexibility in the units you use. I think this is kind of a nice way of putting it. But so putting this into your calculator comes out with 5.59 times 10 to the minus 3. So 5.59 times 10 to the minus 3 meters squared per volt second. And that is a solution for quiz 9.